From the last part, I'm extending that thinking process to the next. So, previously, we have done only till this much, and now we are supposed to do this pattern, right? For n is equal to 3. And how we are going to do that? Again, using the same logic. Let me just cut it and resize, and so that we can have some space for this pattern. How we are doing this? We are just declaring that rows is 3. Let me just change the color, it will be nice. Okay, and you are just printing it, right? Rows. And this will type 3 here, and again you write this. Again this will print 3 here, and if you want another 3, what you will do? Again you write the same thing, right? You will write the same thing. So first row is completed. What you will do for the second row? Once you have reached here, your first step is go to next line, start printing. So first you went to next line. Now what happens? The cursor will be pointing here. Cursor is here according to this line. So printf %d rows. So what happens? You will write 3 here. So this prints 3. Again you will write, this will print 3, and again if you see, this line will also write 3. You observe that for 2 rows I have written 1 2 3 4 5 6. How many? 3 rows, 3 columns. Number of printf is 3, and 3 6. Again I have written this row, and time to write the third row. What can I do? I have to write these 4 lines again here, right? I'm just copying this in order to just save the time, and writing it over here. As another block. So whatever I have written over here, same thing it will also write print 3 3 3. So if you observe this, from here we gone to here, and from here we went to here. From this process, one thing I found is, this is something that we are changing in the program. This thing we are changing by explicitly, and this we are writing explicitly. And imagine that for n is equal to rows as 1, we wrote printf just once, right? For rows value 2, we wrote the printf as how many times? 1 2 3 4 5 times, right? For rows 3, printf we have written is 1 2 3 4 5 6 7 8 9 10 11 times. So can you observe that how many times we are supposed to write this printf? let's say for rows equal to 4, how many times we are writing this printf? The first printf for first row is 4 times, 4 times printf, and 1 time for slash n, 1 time for slash n to come to this row, again 4 times, come to next line for third row, row 3 plus 1, and over here you will write again 4 times and again 1 for next line and again row 4, and you will write 4 times total. So 8 4 0 4 4 16 16 17 18 19 19 times you are writing, 19 times you are writing, right? So based upon observation, I can just see that how many times the printf is being printed according to this pattern. For I equal to 1, I am printing 1. For 2 it's 5, for 3 it's 11, and for 4 it's 19 times. And let's just check for 5. So for 2 and times 2, number of rows and number of columns were 4 elements, total number of elements were 4, and for how many rows I had to, how many slashes I had to use? Only one, that is row minus 1, that is plus 2 minus 1. Okay, sorry, 4 plus 1 is 5. So here number of elements were 3 cross 3, like 3 3 3 3 3 3. How many elements we have to print? Those many printf I want. So therefore 1 2 3 4 5 6 7 8 9, 9, and how many slashes? 1 and 2. 2 means 3 minus 1. 9 plus 2, that is 11. Similarly for 4, so for 4 number of elements we had is 4 cross 4 was 16, 4 4 is 16, and 4 minus 1, that is 16 plus 3, that is 19. We got it as 19. So let's just use this thinking process to extend for n is equal to, n is equal to 5. Again, to write 5 rows, 5 columns, I have to write 25 elements. 5 5 is 25 elements. And how many slashes? That is 5 minus 1, that is 25 plus 4, that is 29 times we have to write the printf. And if I just check for 10, it is 10 times 10, that is 100 elements we have to print, and number of slashes are 10 minus 1, that is 9. 100 on 9 times we have to write this printf. So you can see the painful process that is going through, that I have to write 5 printf for 2 and 3 print, if it is 3 I have to write 9. And one more thing you have to notice here is the number of printf written for one program. Let's say rows equal to 1 and you wrote some number of printf, and if you have to execute the same thing for 4, either you have to change this program and do this for and writes whatsoever printf you need, or you have to create a new file. Let's just say that you need some way to use this file that was already present for n is equal to 1. You want it for future is, so you want to store it. So what is the next way? For n is equal to 4, I have to create a new file and write whatsoever printf you needed, that is 19 number of lines of printf. This is like file 4.c, file 1.c. So if you consider for n is equal to 10, you have to write separate copy of the printf and separate file. So one thing you can notice is storage is being used, wastage of storage. You are wasting the storage, right? Another thing you observed is you are doing the task by writing printf again and again by calculating. You are not just randomly writing it, you have to calculate. Let's say the n value is 100. What value we will get? 100 times 100, that is 1000 plus 99, 1099 lines of printf you have to write. And I don't know how much time it takes, depends upon your typing speed. And this is actually a painful process. We are not doing this type of work in our machine. We want our machine to give any value you give, it should print the required pattern. So you found that this is not useful. First step tools of printf was very long process and not scalable. Scalable means you cannot use one program written to any value of n. Okay, so now you understood what is the problem if I use this only. And in order to come out of this painful process, there are many other tools which are used to improvise this method, and those methods we can use by using other tools that you already know, like if, else, switch, for, while, do while. And let's just think which one comes as a handy. Okay, the first thing, let's try with if. And if I want to write number of rows is 1, if rows, you have to write some condition, right? You have to write some condition, right? That condition is if number of rows is 1, you print one time, and else it is true, and this is for if false. And again you are checking if your rows is 2, and you are writing printf 5 times. So here also you can see the same thing that we were doing in printf, we are doing over here also. The thing is, you are not creating many files that you did over here, that you were doing here. Instead of this, you are just writing using if else format in the same file. But one thing you have to understand is how long you will write this if else. Will you stop at if rows is equal to 100 or 1000? When you will stop? Let's say someone come to my computer and I have written till 100 and he gave 105. My program doesn't know how to print for 105 rows, right? So I can now surely say this won't work. This thinking or tool of if else is not working for this program. So if else failed, and let's failed in the sense it doesn't mean that you cannot use it as a tool, but it is not scalable. For any n your program is not working. Let's go for a switch. Let's try using switch. How can we write using switch? Switch some case. Let's say rows. I think okay, if case 1 print dash dash dash, case 2 print dash dash dash, as many printf you have to write, or break. Any you have to break, right? See, again you are writing number of printf as 11, I think, and break. Again you can see the same problem that we were running through here also is same here. How many times you write this case value? What is the last value of this n? You do not know. Let's say you wrote till 100 and you wrote that 1099 times printf, and someone, your friend, just wanted to curiously know that what this program is doing, and he gave unknownly 105. Your program just cannot handle this input, right? So again it's not scalable. Like you cannot use this particular construct or tool to any value of n. Any value of n does not work for this case. So this switch case also failed. The next thing is for. Let's try with for. What this for is telling. So for, what we have to write over here, I suppose you know this, something that is index, something that we call it as index or iteration. What is a iteration? Iteration, doing similar task again and again, right? And if you observe this pattern, are we doing some iterations, that is doing the same task again and again? Any task that we are doing again and again? Think about it. And the answer is surprisingly yes. How? See the row 1. This is a task, printing 3. And how many times this task has been done? 1, 2, 3, 4, 5, 6, 7, 9 times we are doing the same task again and again. 9 times we are doing the same task, right? So using this for construct, let's just try to verify whether we can achieve this using this tool. So iteration is nothing but some value. Let's say your rows you have given as 3, some value that is keeping track of what this, how many times you have to run through 9, whether it is rows or columns that you have extracted as an idea through your brain, the smart brain, your human brain. So how do you tell to this computer? See beta, I have a iterator, let's just say I, and I want this iterator to run through from 1, I'm just counting from 1 to how many times? 9 times. That is of course rows. We can tell this as rows into rows, right? 9 times you are doing, and you have to increment every time because you are starting from 1 to 9, and you print the rows. What it will do? First time when you come here and your I is 1 and rows is 3, you come, this is true, like 1 is less than or equal to 9, true, and your rows is being printed, that is 3. Again you go here and you will increment the value to 2, and 2 is less than or equal to 9, and from here it is true, and you will print 3. This one got printed, this one got printed. Again you come here and you will change the value to 3 and check the condition, and it is found to be true, and you print the row value, that is 3. Printed this. Now again you go to this value and you found that 4 is less than or equal to 9, true, and printed. By the time you come to here, you realize that okay, this is not the thing that I am doing correctly. I have to have next line. But this seems okay. This tool is working, but I have to think a bit more by actually including some sort of /n. I need to take care of this also. So how we can do this? First thing was, the rows is 2. Now that I was running from 1 to 9 and you were having printf rows, and this was working fine unless and until you encountered some next line. Now the thing is, your construct is working fine for first row, and the next thing you realized is I have to have this condition to break over here, and what is the breaking point and come to the next line? That is number of 3's. How many times 3 has to be printed in each row? that is 3 times. How many times? 3 times, as many as the row value. If row value is 3, you are doing 3 times. If row value is 4, you are writing 4 times and coming to next line. So one observation you did here is this loop, of course it has to run from 1 through 9, but it has to run in two parts. It has to run in two parts. How? One being row and stop, one being column, as you understood from your smart brain. Now you have to tell the same thing to your computer. See beta, now whatever you are doing over here, it is fine, but what I need is I have to split this into 3 rows and 3 columns, not just one row. Now you are thinking how to do this. To this thing, you are actually using for tool to print a row, right? And you are also using for tool to print the second row. Also you are using the same for to print the third row. Everywhere you are using the same for tool to print the rows. The only thing you are missing is how to break this pattern to come to next line, so that we can have 3 rows. So if you consider this as task 1, task 2 and task 3, you have to do task 1 and you have to do task 2 and you have to do task 3. And from combinatorics, this is something that task 1 followed by task 2 followed by task 3 can be summed up to a whole task. The whole task was printing this pattern, and you have divided that task as task being 1 printing the first row, task being 2 printing the second row, and task being printing third row. This is simple concept. You are doing the same task again and again by using some subtask in order to come up with the logic. Now let's just convert this thought process to a programming construct. You already got to know that this for is helping me to do the particular tasks, and I have to find out just what is this breakpoint. How can you do that? Again, if you think through the process, you have to do the task 1 followed by task 2 followed by task 3. Then only you can perform the whole task as a whole. Okay, the task 1 was very simple. It has to go from I equal to 1 to number of rows. Now this is holding number of rows. Again, once you write some row, you have to repeat the same task again with some modification to this construct, and it is in between this task 1 and task 2, right? See, 3 and your task 2, this is task 2 and this is task 1. Your this task of breaking the point till number of columns as 3 is in between the task 1 and task 2. Means it is actually depending upon what happened after task 1 and before happening of task 2. Means you are not breaking the task and you are just doing this small task of printing next line printing next line and going to this line as a subtask. So your subtask actually comes here. Your subtask actually comes here because you are doing task 1. Again you go to here to do task 2 and your subtask comes under your main task. So how do you define this subtask? Let's discuss now. Let's discuss this now. Your main task was this the same thing? Sorry. Yeah. And your subtask is being. So if you again consider the task 1, when is the breakpoint that you are just encountered? As many as the number of 3 is printed for 3 times. And how can we guarantee that we are actually printing only 3 columns? By using same logic of this, right? Instead of rows, we are now transferring it to column. We are just making sure that we are not going after number of so and so column, and the number of column that we found over here is actually 3. And how to write that? For again this task is, let's say, column being from 1 and this column has to run through 1 and 3 and column plus plus. So first our task was this. In order to understand what this task is doing, we have to understand how many times this small task has to do the subtask, that is as many rows as the columns or as many columns as the rows. Basically number of rows and number of columns is same. So this is your row and now this is your column constraint. Now what you have to do here, your task was from task 1 to task 2, your task was printing 3, right? How many times? As many number of columns. That is, you are just printing the columns. columns. Okay, sorry, number that you have given over here as 3, and after you do this task of 1, now you before you jump into task 2, how will you get to start of this task 2? After you complete this, right? After you complete this, after you run through this condition less than or equal to, sorry, and how will you do that? Just saying, please Baba, before you go to the task 2, just print the next line. Just print the next line, then go to task 2. So initially it was waiting for task 1 to complete, but this task 1 is having some constraint that how many times this 3 has to print, and this 3 has to be printed based upon the number of values of rows. So here I am using this 3 and this is as columns. Let me write this in as general. So how can I write this as in general? I am just giving this memory location as rows, same as how you are storing in your brain cells, and I am just asking user, array user, please enter some number, and this printer just entering that number, and it is to be stored in the respective memory cell, where not memory cells, sorry, in respective memory location inside your computer. And now you are writing your logic. How you are writing your logic? First you are doing the task as row. How many rows you are having, how many number of elements you are having in the rows. If you consider, not just every time if I take this you will get confused, right? Let me take 4 4 4 4 4 4 4 4 4 4 4 4 4. How many times you have to do this task? The same number of times you have to do this task is the number of value of this rows. So less than or equal to rows, and row plus plus, and again you have to do the subtask. This is task 1, you just wrote task 1, task 2, task 3, sorry, this one, and task 4. What I told you, before doing task 1 to task 2, I have to do something over here and something over here, so that this pattern is being imitated. How will you do that? By using the same construct, by using the same logic, using for column ranges from column 1 to number of rows, this value, till that I will be keep printing this. And what I will do, I will print the respective columns value that I got this from a user. And after this one task is done, I will just go into next line to do the second task, of course, and I'm done. Now this task is actually managed by this for loop, and this completes my whole logic for printing the pattern. Now see why this thing is, the first thing I have to ask is whether this thing is scalable, in the sense, even if you gave value of 10,000, will it work? Will it work? Check it. Will it work? What are we doing over here? What are we doing? What are we doing? What are we doing over here? What are we doing over here? One second, sorry. We are not worrying how many tasks we are doing. We are just giving as many tasks, it is coming from the number which is over here, right? Whatever we are writing over here, whatever the value that user is entering, those are the values, those are the times we are doing this particular task. And what are the constraint of this small task, subtask? Again, we are just going from initial value as 1 to the number of times the user want me to print it, and this can guarantee the scalability. Means for any value of n, it will work, right? And one more thing, we were able to achieve what we were able to achieve. Just think, what was the problem that we were having in this? If you just consider this problem that I just explained before, and with this approach, what can you achieve? That your file number of files required to execute any value of n is actually 1, right? Within a single file you are able to achieve the whole logic of printing a pattern for any n value, any value of n. So actually this holds the complete conclusion of how you can just print the pattern like this. And if you have any questions or any point in time you did not understand anything, please let me know. I'm happy to answer and explain this again, so that you can think about any pattern in future. Okay, Thank you for your patience.